All right, welcome back. So in the last one, we talked about simplifying radicals and we went over the multiplication and the division properties with radicals. Now we're just going to talk about operations. So our basic operations when we include addition and subtraction with our radicals. So we can only combine like radicals, meaning the inside of our radical, our radicand, has to be the same number in order for us to add. So like this first one, or subtract, let me put that in there too. This first one, I am now going to treat this as 6 plus 9 radical 11. The radical does not change. I'm not adding the 11s together. I'm adding the fact that I have 6 of the square root 11s and 9 of the square root 11s. So together, that makes 15 square root 11s. And so that's all that it is. It's just like as if those radicals were x's or y's. We're combining like terms. So same down here. This is a 1 in front of this square root 3. So I'm truly just doing a 1 minus 5 and then taking it times my square root of 3. So we end up with a negative 4 square root 3. And no, you don't have to show this in parentheses. I'm just showing you on the video what I'm thinking in my head. But that's what it is. You can only combine like radicals. So if they're not like radicals, like we have right here with our 5 square root 3 and our square root of 12, then I need to see if I can simplify to make them like radicals. So square root of 3 won't simplify, but 12 does, right? And 12 is, you can either do 2 and 6 or 3 and 4, and we know that 4 is 2 and 2, meaning that we're going to have 2 square root 3 as my simplified radical. So now I'm going to rewrite this as 5 square root 3 minus, and now I'm going to replace the square root of 12 with the 2 square root 3. So 2 square root 3. And now I can take 5 minus 2 and get 3 square root 3. And that is our answer. So again, when they're unlike radicals, we're going to simplify them and see if we can get them to be the same. Now, if I can't get them to be the same, then I just leave the expression as is. So we'll have some times where we'll see that. All right, so here we have multiplying radical expressions. So it's just the distributive property. So like this first one here, I'm going to take 10 times the square root of 10 times the square root of 6. So we're going to end up with the square root of 60 plus the square root of 10 times the square root of 3, or not square root of 3, times 3, where we get 3 square root 10. Now from here, I need to simplify that 60. Now if you wanted to start by not actually multiplying your 10 and your 6, then you could have just started with them being your, where we started our simplifying. So 10 is 5 and 2, and 6 is 2 and 3, meaning I can take a 2 out. So I'm going to have a 2 out to the front, and I'm going to have 5 and 3 left inside. So we're going to have 2. I don't know why I put a parenthesis. 2 square root 15 plus 3 square root 10. And so this would be that example of 15, square root of 15 and square root of 10 are not the same radical, and so we cannot combine them, and so that's our final answer. Now when we look at B, we have a binomial with a binomial, right? So we are going to have to double distribute. So I'm going to take this square root of 6 times square root of 6, which is going to give us 6, and then I'm going to take square root of 6 times the square root of 3, which will give us a positive square root of 18. I'm going to take the negative 2 square root 3 times the negative, or the square root 6, which will give us a negative 2 square root 18. And then we're going to take that negative 2 times the negative 2 square root 3 times square root 3. So we will end up with a negative square root 3 times square root 3 is 3. So negative 2 times 3 is a negative 6. And then I'm going to combine like terms. So 1 square root 18 minus 2 square root 18 is going to give us a negative 1 square root 18. And 6 minus 6 is 0. Now 18 is not the most simplified, right? Because I know 9 goes into it. So that's 3. So this becomes a 3 square root 2. I'm going to take that 3 times the negative 1 already on the outside. So we end up with negative 3 square root 2. So again, I'm using double distribute. I'm combining like terms still. And then I'm just simplifying from there. That's what we do. When we multiply, also remember that when you take the same, like when you square a square root, so when we took the square root of 6 times the square root of 6, that's just going to become whatever's in the square root. Same with our square root of 3 times our square root of 3, it just equals 3. Whereas square root of 6 times square root of 3 is still a square root because they were not the same number. All right. Now, this is actually, I'm going to make this into a separate video. So that was our adding and subtracting, making sure that we have like square roots before we add or subtract. And then we did our multiplying where we just distribute through when we need to distribute. And so I will see you on the other side where we talk about conjugates.